Hello and welcome to this video on graphing cosine functions. The objective is to be able to graph cosine functions, and we're going to look at, again, introducing the amplitude into graphing. We won't have any midline shift, which we'll talk about in the next lesson, but we are going to look at the period of cosine and the amplitude of a cosine function in this video. For prior knowledge, I would like to again draw your knowledge back to the unit circle. Remember that the cosine function, cosine of theta, that is always equal to the x coordinate of a given angle. So here, when we're asked what is cosine of 0, well, we would look at angle 0 and the cosine value is 1. So that's 1. For cosine of pi over 2, I'm not sure why that's repeated twice, but the x value is 0. So I have 0. And pi, if I go ahead and go to pi, the x value is negative 1. At 3 pi over 2, the x value is 0, and at 2 pi, it is again 1. So remember in the last video, we used the angles as our x values and the outputs, the coordinate locations as our y value, and we generated our graph. And we'll do the same thing here. I'll use 0, 1 be my first coordinate. Pi halves 0 be my second coordinate. Third coordinate would be pi negative 1. 3 pi over 2, 0, and last but not least, 2 pi comma 1, which I think is right about there. And thus we get cosine of theta, this graph. So here is cosine of theta, and again, this is just one period. And again, notice that the period is 2 pi. So every 2 pi, this repeats just like sine, but the main difference with sine is sine theta started here at the origin, and it looked something like this. The cosine function, again, starts at a maximum. And if it's negative, it would start at a minimum. Okay, and there is cosine of theta. So really quickly, again, 4 things that you should notice. Again, the amplitude, the max and the mins are at 1 and negative 1. And sorry, this is for sine of theta. Max and mins are at negative 1. Period is 2 pi. This is the same as cosine theta. Exact same kind of things to notice, except notice that the starting location for your periods occurs at a maximum. So when we first start plotting this function, we will start at a maximum, okay? And which is, of course, our amplitude, so 1. So again, here are our steps, and the steps are exactly the same as the sine function, again, except when we plot our first point, it will be at the maximum, or if we have a negative amplitude, it'll be at the minimum. So let's go ahead, let's look at some examples. So here we're asked to graph cosine of theta equals y for 3 periods. So step 1, I'm going to go ahead and plot my maximum point, which occurs at 1. And this is going to repeat every 2 pi. The period is, again, 2 pi. So I have a point here, and a point here. So this is just 2 pi. So I'll focus first on the first period here. And again, remember, with these functions, you want to split them into fourths. So I'll cut them in half. I'm going to have a key point here, a key point here, and a key point here. So I essentially broke it into fourths. And remember, the cosine function starts at 1, and it's going to go down. So I have an intercept here at pi over 2. I have a minimum at pi. I have an intercept at 3 pi over 2, and then a maximum. So here is cosine theta. Okay. Now, if I want to continue this, so I'll draw another period. Now again, I kind of split it, and the graph, the way it's split up, is conducive to each unit being a key point. So I go over, so this is going to be an intercept, minimum, intercept, maximum. And we have another function. Oh, there's another period, sorry. Okay, and last but not least, now I'll do it in the negative direction. So again, this is maximum, intercept, minimum, intercept, maximum. And here is another cycle or another period of the cosine function. So notice this kind of looks a lot like sine theta, and again the only difference is that sine of theta would start at the origin. Sine of theta would look something like this. Okay, so they are extremely similar. Okay, except again, cosine of theta starts at the altitude, and sine of theta starts at the origin. Okay, so this is a practice problem. Please pause the video at this point, and I would like you to go ahead, try this on your own. When you're done, click play again, and you can see the answer, and you can pause it and double check your work. Okay, and here is the solution. So hopefully you got that right. Again, double check a couple of things. One, is your amplitude at 1? Is your maximum and minimum at 1 and -1? Also at 0, you should start at a maximum. Okay, so it should go maximum, intercept, minimum, intercept, maximum. Okay, so again, in this video, we talked about cosine of theta, we introduced it, and we graphed the parent function for 3 periods, and then here the practice problem was for 2 periods. The next video, I will talk about identifying amplitude, and we'll look at a couple of examples with graphing cosine theta with a different amplitude.